the previous video, we have discussed about axioms and postulates of Introduction to Euclid Geometry. Now in this video, we will discuss Chapter 5, Introduction to Euclid Geometry, Class 9, NCERT, CBSE. So the first question of the NCERT exercise 5.1 is, which of the following statements are true and which are false? Give reasons for your answers. Only one line can pass through a single point. From a single point, students, we know from a single point, this is a single point. If I say a single point, so only one line can pass? No, many lines can pass through a single point. So this is wrong. First is false. Second, there are an indefinite number of lines which pass through two distinct points. There are two distinct points. From two distinct points, only one line can pass. So how indefinite lines can pass? So second is also false. Third, terminated line can be produced indefinitely on both the sides. Yes, terminated line. This is a line. So this line we can extend it to both the ways. So terminated line can be extended. So third option is true. Fourth, if two circles are equal, then their radii are equal. If two circles are equal, means circles are measured from the radius only, and if the radius are equal given, so they are congruent. So it is true. If two circles are equal, then their radii are equal. Fifth is, in figure, if AB equals to PQ and PQ equals to XY, then AB equals to XY. Yes, if I say X equals to Y and Y equals to M, this means X equal to M. Hence, fifth option is also true. Now comes second sum. Students, second sum is the basic definitions you have done in previous classes also. First is parallel lines. Parallel lines are those which do not intersect at any point. Means their intersection point is 0. They never intersect with each other. Second is perpendicular lines. The lines which are having an angle of 90 degree are known as perpendicular lines. Angle between them is 90 degree. Third is line segment. Line segment, when we join two definite points, then the line joining those two definite points is known as line segment. Next, radius of circle. Radius of circle is the distance from center to any point on the circle. It is the distance from center to any point on the circle. Last, fifth is square. Square is a quadrilateral in which all the sides are equal and the diagonals are also equal. And if the diagonals are equal and the sides are having 90 degree angle, means sides are perpendicular also. Now next is your third sum. In the third sum, what they say, consider two postulates given below. Now two postulates are given below. First, given any two distinct points A and B, there exists a third point C which is in between A and B. Second, there exists at least 3 points that are not on the same line. Do these postulates contain any undefined term? Are these postulates consistent? Do they follow from Euclid's postulates? Explain. So we have to give the answers to these questions. So see third sum now. Firstly, they have asked about undefined terms. Undefined terms are line and point. Both the postulates are consistent. Why they are consistent? Because they represent two different situations. They are representing two different situations, so they are consistent. First says that given 2 points A and B, there is a point C lying on a line in between them. This was the condition for first. Second says given A and B, you can take C not lying on the line through A and B. Now what they ask in the statement, both these statements do not follow from Euclid's postulate. They have asked that do these postulates contain any undefined term? We have discussed. Are these postulates consistent? We have discussed. Do they follow from Euclid postulate? Both these statements do not follow from Euclid postulates. However, they follow from Euclid's axiom. Which axiom? That is given below. Given two distinct points, there is a unique line that passes through them. So this was your third sum. Now is fourth sum. In fourth sum, what they say, fourth sum, if a point C lies between points A and B, sum number fourth, if a point C lies between two points A and B such that AC equal to BC, AC equal to BC, given AC equals to BC, then prove that AC is half of AB, explained by drawing the figure. To prove AC is half of AB, proof. In the above figure, AC equals to BC given. Adding AC on both sides, AC plus AC is equal to BC plus AC. Here what we will write, equals are added to equals, wholes are equals. Now 2AC, what is AC plus BC? AB, so AC comes out to be half of AB. This is what we have to prove. This was fourth sum. Now is fifth sum. In fifth sum, what they say, in fifth sum, in question 4, point C is called midpoint of line segment AB. Prove that every line segment has one and only one midpoint. Now A, B, what they say, C is called midpoint of AB. Prove that every line segment has one and only one midpoint. Let us suppose that D is also a midpoint of AB. Now AC equal to CB given. Therefore AC AB is equals to, we are given AC equal to CB. This means AC is half of AB. Also AD equal to DB by assumption. Therefore AD is half of AB. This is your first, this is your second equation. From 1 and 2, AC is equal to AD. AC is equal to AD, which is not possible. So our assumption is wrong. Hence, every line segment has one and only one midpoint. So our assumption was wrong. Hence, a line segment has one and only one midpoint. This was your fifth sum. Now, sixth sum. In sixth sum, figure is given to you. A, B, C, D points are given to you. Given AC equal to BD, sum number fifth. Given AC equal to BD, to prove AB equal to CD. Proof. In the above figure, AC equals to BD. Given subtracting BC from both sides, AC minus BC is BD minus BC. What we will write? Equals are subtracted from equals, the remainders are equals. AC minus BC is BD minus BC. Now what is AC minus BC? AB. And what is BD minus BC? That is CD. Hence proved. Now is last sum, seventh sum. Why is axiom 5 in the list of Euclid axioms considered a universal truth? Axiom 5 states that the whole is greater than a part. For this, let us consider one example. AB. Here AB is equals to AC plus CD plus DB. This means AC is greater than, this is the whole, and these are the parts. So AB is greater than AC, or AB is greater than AD, or AB is greater than DB. Hence we can say that the whole is greater than the part. Students, in this video we have discussed chapter 5 Euclid geometry. So for the next chapters, do see the next videos. Thank you.